Okay. Hi, everyone. Good day, good afternoon, evening, morning, wherever you are. Hope everything is fine with you and your loved ones. Welcome and thank you for joining the Geoscience and Geoenergy webinar of 1st of April 2021. Now, no pressure, Sebastian. We should come up with some April 1st joke or something during this webinar. Let's see if we can make that. Or the speaker as well. Today we have the pleasure of hosting our dear friend and colleague Anna Suzuki from Japan. She's actually our first keynote speaker from Japan, and we hope this is just the first, and many more colleagues will also volunteer, or we will also definitely approach them to host from different countries as well. So thank you, Anna, very much for graciously accepting our invitation. I'm going to just introduce Anna to the audience, and then the lecture will start, like always. Anna is assistant professor in Institute of Fluid Science at Tohoku University, and she holds the position since November 16th. She holds her BSc, bachelor degree in mechanical engineering, and MSc and PhD in environmental studies, all at Tohoku University, where he actually works today. After her PhD, she became a postdoc researcher in Energy Resources Engineering department at Stanford, and we actually had shared a bit office as well with Anna the time she was at Stanford. And she spent there for about 2 years, and then took the academic position back home in Tohoku University. Her PhD and also postdoc visit at Stanford were all sponsored by Japan Society for the Promotion of Science. Her research focuses on mass and heat transfer in fractured networks, especially in geothermal reservoirs. Recently, she is also focusing on an important subject on dialogue and co-creation with citizens on the use of local resources, and have begun activities that will promote a change in consciousness of people. So as we know all as geoscientists, that connecting with society, involving them and not just informing, and so are at the core of our new scope in the geoscience and other technologies as well. So it's extremely important to host frontiers like Anna, who are actually leading on this subject and would like to also share their findings with us. To the audience again, please take a look at Anna's Scholar page at Google. We are going to post her Google Scholar page address to you all to go and look and study her papers, and also her research lab with the address that I'm going to also post it, so that you know which research lab she belongs to, and please get in touch with her on any geoscientific or geoenergetic questions or collaborations, but also about society and acceptability of the geoscience projects. It's a pleasure and honor to host you, Anna. Thank you very much for accepting our invitation, despite it's quite late at night, about 11 midnight in Japan. Please note, audience, please note that the lecture would last for about half an hour, like always, and then followed by questions and discussions that Sebastian will chair. So, Anna, we are all looking forward to hearing your talk. Thank you very much once again.
Okay, thank you, Hadi. So to introduce me, it's a great honor to have a talk in this seminar. So today I'd like to talk about the fracture network and the community network for co-create of the geothermal resource utilization. So I'm Anna Suzuki from Tohoku University, Japan. So before I start my talk, I want to explain why I choose this title. So Japan has many natural disasters like an earthquake, the tsunami, typhoon, or heavy rain. So therefore, the disaster resilient and sustainable society is the key to survive in Japan. So several past disasters reminded me of the importance of coexisting with the nature. Therefore, I've been working on the geothermal energy. So this shows the geothermal potential and the power plant capacity in several countries. And Japan has the third largest geothermal energy potential in the world, while we haven't used the energy as the electricity yet. The right graph shows the ratio of the usage to the total power generation and the ratio of the usage to the geothermal potential. So the upper side means that geothermal energy is used as a high percentage in their country, and the right side means the largest geothermal potential is being used. So the upper right corner means a country with a good example of geothermal energy use. However, our country, Japan, has fallen far behind the other countries. So why hasn't Japanese geothermal development made progress? I want to look at it from the two sides. The technical and scientific problems are not only for Japan, but the geothermal system is very complex and its development has a high uncertainty. This is why I have been working on the geothermal reservoir engineering and focusing on the understanding of the flow between rocks through the complex fracture networks. On the other hand, in Japan, the geothermal energy has been used for thousands of the years as an onsen, in other words, for bathing. So if you've ever been to Japan, you know that the Japanese love onsen. So I also like onsen. Because of the strong opinion of the onsen operator, there has been a lot of opposition of the use of the geothermal energy for electricity. I have been thinking about the development of the geothermal power generation in my research for good reason. But because the technology alone will not change society, recently I have been focusing on the social acceptance in the local community network. So today, although there are two different networks, I would like to talk about my research specialty, fracture networks, and my social activity of the community networks that are related to extend our technology in society. Okay, first let's talk about the fracture networks. So characterization of the fracture network by topological data analysis. So I focus on the shape and the feature of the networks. In geothermal reservoir, the fluid flow is controlled by fault and fracture networks. The tracer tests are the only way to directly measure the fluid from the reservoir. Usually, solute such as dye is injected into a well, and the concentration of the solute is observed in a distant well. We call this change in concentration is a tracer response. In order to what happens in geothermal reservoir with a measurable data, the modeling is quite important. For example, the conventional method uses a discrete fracture network to describe the complex network structure with large number of rectangular or disc-shaped fractures. The parameter fitting is performed until the tracer response matches the maker simulation solution. And then we explore the plausible combination of the parameter. The conventional methods are powerful when many data are available. But when the measurable data is limited, such as in the early stage of the development, these models include too many input parameters that we need to determine, so that this approach is high uncertain. I wonder, is there a simple model or intrinsic description of the flow of the fracture network that can be expressed as well as possible based on the measurable data? So we focus on the topology. The topology recognizes the hole. For example, this donut and this light blue cup has a hole through them. Then this donut is topologically same as the light blue cup. Instead, the dark blue cup doesn't have a hole because it doesn't connect it. So then this cup is not recognized as the same as this donut and this light blue cup. The persistent homology is a representative topological data analysis for computing the topological and geometric feature of the shape. So since we can look at the data and shape in a different way that we have in the past, so the persistent homology has been applied in the several research fields. So let me apply the persistent homology to fractured rock. So this is a schematic of the rock with the fracture. And this shows the cross-sectional of this rock. We consider the yellow part as a rock skeleton and the white part as a fracture connected from the inlet to the outlet to the outlet. So it means that it can make a flow path through the rock. Persistent homology can recognize such hole, like flow path, as a one-dimensional hole. In contrast, if there is a fracture, like independent fracture not connected to the other, this recognized as a pore and two-dimensional hole. If we only use the one-dimensional hole, persistent homology detects only the fracture functioning the flow path. So in the persistent homology analysis, we think or seek of the object voxel by voxel. So during the thickening process, when closing the hole, this flow path, the flow path is considered dead. Then the voxel increment is expressed by the parameter depth. So by using this depth value, the persistent homology can detect the smallest aperture in a flow path. If we use a feature of the persistent homology can detect only the fracture functioning the flow path with the aperture. I wonder if the persistent homology can be an intrinsic description to express the flow in the fracture networks. So therefore, the objective of this study is to quantify the fracture network and to evaluate the flow and transport behavior by persistent homology. So in this study, we generate a synthetic fracture network and quantify the image data by persistent homology. By using the quantified data, we try to estimate the permeability of the fracture network. So today, I'm going to introduce our work on the estimation of the permeability based on the persistent homology. First, we generate a synthetic fracture network model with the disc-shaped fracture. The top and the bottom are open boundary, while the sides are closed. So water only from the top to the bottom. Then we can control the fracture parameter, aperture, radius, number, and orientation. Then we prepare the orthogonal distribution of the fracture network, which has the vertical and horizontal fracture. And also that we prepare the random distribution like this network. Then after prepare the fracture network, the fracture network data was converted to the binarized image and analyzed by persistent homology. Then we use the open software home cloud. I mentioned before the persistent homology thin or thick of the object. Here is a yellow rock skeleton here. The process is called filtration. So here I draw the cross-sectional image of the flow channel, flow path. Here. The original image is here. By computational reason, the time is set to -1. And the thinning process goes to negative, and thickening process goes to positive. If we continue to thin the yellow part, the image becomes the all white. Then go back in thickening process. When the hole, the flow path appear. So we consider the hole was born, so that time is called the path. The thickening process is continued, then the hole is disappear. We consider the hole was dead, so the time is called death. One flow path has one flow path is described by the one death and birth pair. So if there are multiple flow paths, we can obtain the multiple birth and death pair. So this multiple birth and death pair can express a complex flow path. In addition, the presence of the hole in the original image is when the birth is negative and death is positive. So therefore, the number of the flow paths in the original image is the number of the birth-death pair with negative birth and positive death. And the aperture can be described as a 2 times death times its resolution. So we use this feature. So here, these are the results of the persistent homology analysis. The left figure shows the result of the estimation of the fracture aperture for 3 orthogonal networks with a single side of the fracture aperture 0.2, 0.6, and 1 millimeter. In contrast, the right figure shows the result for the random distribution of the fracture network. X-axis is the actual aperture of the fracture network, and the y-axis is the estimated aperture of the persistent homology analysis. We can see that although some of them are overestimated, the estimated value has correlation with the actual aperture. For example, if the fracture is overlapped together, the aperture of the flow path is expected to be larger than the width of the fracture. Therefore, the persistent homology can be used in the estimating the aperture of the flow path. Next, we conduct the direct flow simulation with the same fracture network by using the open form to calculate permeability. By using the open form, we obtain each flow rate and pressure gradient between the inlet and outlet. Based on the Darcy's law, we can calculate the equivalent permeability in the whole model. To derive the permeability by using the parameter obtained from the persistent homology, we consider the fracture permeability. If we assume the fracture is a parallel plate, the flow rate can be described by the fracture aperture. The permeability of the multiple flow rate can be written by this equation. And these parameters can be written as a multiple birth-death pair obtained from the persistent homology analysis. So here is the result of the estimating for the permeability of the synthetic fracture network. X-axis is the permeability simulated from the direct simulation, and the y-axis is the estimated result based on the persistent homology. The orange shows the result of the random distribution, and the blue shows the result of the orthogonal distribution. So the estimated value has high correlation with the simulation permeability. We also apply this equation to the other structure. So we use a 2D image for a structure and 3D log image like this. And the red color shows the result of the estimation of these 2D power image. And the green one shows the result of these 3D log images. And this purple shows the result of the barrier sandstone. Now, although it's a bit overestimated, this simple equation can estimate the permeability of the several rock images. So we conclude that we estimated the permeability rock with a simple estimation formula based on the persistent homology. Here is a middle summary. And by using the synthetic fracture network, we propose a method to estimate the permeability from the image data based on the persistent homology analysis. And the next step, we will generate the several tracer response data from the direct transport simulation. And we will investigate whether it is possible to estimate the subsurface structure represented by the persistent homology based on the tracer data. Okay, next, I'd like to change my talk topic to community networks. So visualization of the change in consciousness and behavior in Waku Waku network. This talk may be unique for the Japanese culture, but I hope it will help you to think about the relationship between the science and technology and the society. As I said, in the case of the geothermal development, the operator or researcher like us try to promote the science and technology for good reason. But the development is often opposed by the hot spring onsen owner in the local community. The hot spring owner do not only make a living from the hot spring, but also they believe the hot spring are a blessing from the God. So therefore, it is necessary to have science and technology accepted by the stakeholder who do not understand the logic alone. So it is important to consider how to get the stakeholder to accept when logic doesn't work. In addition, although the energy is supposed to be an issue that all of us think about together, the energy issue tend to be seen as a someone else's problem. So I think it is necessary for all the people to change our consciousness and behavior. In thinking about how to change our consciousness and behavior, if we organize an inquiry in the design process in terms of the aesthetics, ethics, and logic, it is believed that the problem solving depends on the problem setting, and the problem setting depends on our sense. In other words, our behavior and action is depending on our consciousness and our value, and it's depending on our feeling. So if we have different consciousness and value with other people, and even if we try to explain our technology or research logically, the other people doesn't care, and this logic doesn't work for other people. The dialogue is a place to exchange information on our feeling and consciousness and value with people who have a different value and background. If people interact and exchange our feeling and consciousness with other people, so we may be able to update our feeling and value each other. The more diverse the people with whom interact, the more updated our information will be, and the more likely we are to change our consciousness. this would help lead to our empathy and common problem setting. Then, even if we solve the problem differently, we may be able to accept others' behavior and action in this case. We have been conducting the interactive dialogue workshop in the community to encourage people to change their behavior and consciousness. And we sometimes have a workshop about the region resources like geothermal energy, and sometimes have a workshop about town building. I'm seeing the participants change their consciousness in the workshop by interacting with other people. However, on the other hand, most of the participants who gathered were the people who were highly interested in the theme originally. And those who were less interested in the theme would not even gather at the place that could be a trigger for change their consciousness. So my research question is, how can we gather a variety of the participants, including those who are uninterested? So here we propose a lifestyle evolution, waku waku as life. So, waku means well up, and waku waku means excited in Japanese. So the idea of the waku waku as life is that the onsen is well up and the people are excited with the onsen and the nature. So coexisting with the nature is important, but we want to move forward it with exciting. So far, in the Waku Waku camp, in the Waku Waku as life, we have the events that combining the hot spring with something new with social issue. So we had a remote work camp at the onsen area before this pandemic. Since most of the Japanese people work in the urban area like Tokyo, the people have to commute a long hour. And many people become sick due to overwork. In contrast, in the rural area, the onsen area, the population is increased. Historically, Japanese people have been curing the disease with a hot spring. Therefore, I wondered if it is possible to promote the remote work at the hot spring area. Then people come to the onsen area and the people become healthy. And in addition, this would help to use the geothermal heat directly in hot spring areas. We have also conducted a kids camp for working parents and their children and outreach activity to listen to exciting research talk in hot spring areas. And most of the participants join the events just because it sounds fun. But thanks to the fact that it sounds fun, we have succeeded in creating a place where people from the different field, different industry, different generation, different region can mix together. So let me explain what the Waku Waku camp is. I try to consider the scientific engineering research first. I think our engineering research is a problem solving, and it's in the logical phase. Usually, my presentation starts from to increase the use of geothermal energy. We want to understand of the phenomena, blah, blah, blah. So we do the experiment and or simulation, blah, blah, blah. So in the science and engineering research, it is necessary to explain each item in an orderly and logical manner. However, for example, there is a person A who doesn't care energy resources, but she's afraid of the illness. For person A, the energy problem is not in her consciousness. Then Even though I try to say this is for increased use of geothermal energy, blah, 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 it doesn't matter for person A. Then they may she not listen to our research and not accept our technology. So we need to keep in our mind what is valuable or problematic for us is not necessarily valuable or problematic for others. So then, in the Waku Waku camp, I say that let's Waku Waku in onsen area. So let's excited in the hot spring areas. Me and the person A, both of us take a bath and feel so good in hot springs. Then I may think, oh, onsen, hot spring is one good example of the direct use, while the person A think, oh, hot spring would be healthy. Then the person A, who is afraid of the illness, would upgrade her consciousness to health with the hot springs. If so, both of us can lead to common question, how can we use the hot spring sustainably? Then we may be able to start the co-creation of the use of the geothermal energy. So in the Waku Waku camp, there are people who are interested in the use of local energy resources like geothermal energy, but also people who came because it sounds fun. The participants can feel the local resources and stimulate our feeling by interaction with other people. So this approach from the feeling aesthetics would help to update our feeling, and is expected people change our consciousness and behavior for coexisting with the nature. So by carrying out more and more activity of the Waku Waku camp, I'd like to involve a variety of the people from the different fields to the energy resource community and the geothermal society like you. So here is second summary. So in Japan, not only the development of the technology for geothermal, but also the how to involve the uninterested people are important. The Waku Waku camp has the potential to involve a diverse range of the people by starting from the sense of fun. Next step, I'd like to have this question. Can we measure the change of the consciousness in the Waku Waku camp? And are there a way for the people to participate even if they are not physically present? So in my research, I will try to visualize the change in the consciousness and behavior and visualize the people's opinion inside and outside of the Waku Waku network. Finally, I'd like to summarize my research characterization of the both fracture and community network by topological data analysis. Okay, so here is a reference of my talk, and thank you very much for listening.
Okay, thank you very much, Anna, for the very interesting talk, both on the technical side, but also responsible innovation and involving society for the technology, especially in this case, geothermal. I see already many questions posted, and I expect much more to come as well. So without any further ado, Sebastian, please take over.
Yes, thank you very much, Anna, for a great talk. And I had the pleasure of visiting Japan 4 years ago and enjoying the onsen. So I'm all up to Tohoku, and I went for a long bicycle ride in 3 degrees centigrade in Edinburgh this morning. So I wish I would have an onsen nearby to just warm up. So, but going back to the technical questions that we have from the audience. So Florian is asking, thank you, Anna, for an interesting talk. You observe impressive correlations between pH and the permeabilities of your fracture network. I wonder whether you can comment what properties of a fracture network would ruin that correlation. So always going to work, or is there something that is going to make your approach not work?
Yeah, so maybe it's better to share. So now can you see my slide?
Yeah.
Okay, so yeah, some of them, some of the results are overestimated, and I think it's caused by the tortuosity or some like more complex structure. And in my assumption, the flow path is a parallel plate, so it means that the flow is very straight. So if the flow path has some tortuosity, then this simple model doesn't consider the tortuosity. So so the next step, I'd like to find any relationship between the persistent homology or some topological data analysis and tortuosity. That is my concern now.
Thank you. And just to follow up with my own question, you assume that the rock matrix is always completely impermeable, so it wouldn't work, say, for fracture network in a somewhat permeable sandstone matrix, right? Okay. Thank you. So coming to Yuang's question, he asks, thank you for the interesting talk. Would your characterization method work for field scale outcrop fracture networks? Have you applied it to the field as well? So you showed your numerical models. What if we take data that we collect from outcrop analogs? Would this work?
Yeah, thank you for your question. So I haven't applied my approach to the field scale because our approach have to use the image data, and the image data is very sensitive of the resolution. And if we can obtain the high resolution the fracture network in the field data, then yeah, I would like to apply our method to the field scale. But I think the problem may caused by the resolution of the image data.
Okay, thank you. And that probably answers the question that Tan has, but putting it out again as well. Says, thank you, Anna Sensei. I think your work is impressive. Do you think we can upscale fracture networks from the core to the field scale?
Yeah, I think almost the same question. Yeah, I think we haven't applied to the field scale, but yeah, if we obtain the good resolution of the field image data, then I would be happy to apply it to field scale. Yeah.
As you're answering questions, more come in. So there's another question from Florian, who's listening intently. And he just wonders, picking up on the outcrop question, 2D versus 3D, how does pH change? So you're going from 2D to a 3D system.
So yeah, so the currently we have to if we consider the 2D or 3D, we need to consider the depth of the fracture. And now for the 2D and the 3D, we have some assumption to assume the depth. So I think the difference between the 2D and the 3D is how to consider the depth of the fracture. Yeah, if we use the outcropped image of the 2D, yeah, we need to think about the how connected of the fracture inside of the rock.
Okay.
Yeah.
Thank you.
Yeah.
So another question from Yuan. And he wonders, can we apply your framework to other flow regimes like slip or transitional flow in which Navier-Stokes equation may not be appropriate? So what if you have some other non-Darcy type flow problems?
Yeah, thank you for the question. Yeah, my approach is to assume the Darcy's law, and that's why we can derive the cubic law. So, but if that is a non-Darcy's law, we have to consider the different way. Yeah, I haven't considered the different flow regime. Yeah, but interesting.
I'm going to change questions now to the second part of your talk. And the first one is a comment from Larry, and says it's so intriguing to connect nature science to society. Thank you, Anna. And Leda has a question. It says, thanks for the interesting talk. How did people respond to your invitation to come to the camp? Did you study if all invited people attend, and if not, why they did not come?
So I think my invitation, usually I use the like Facebook or email or like I just send a bunch of the people, and I didn't care if the people who doesn't respond.
Okay.
Yeah, before. So, but I think why I started the Waku Waku camp is if I say, oh, this is the camp for the energy problem, then the many variety of the people doesn't come, I guess. So so that's why I just say, oh, let's go to the onsen. It's like a trip or travel. So then people just want to come. So yeah. So I think if the people want to have fun, then people come. So I think
it's an aspect of joy and enjoying rather than the technology or the science.
Yeah,
it's definitely absolutely fascinating. When Rosalind Archer earlier this year gave a talk, and she also touched upon the importance in New Zealand of really bringing the use of the geothermal energy do this in connection with Maori population who have a very different understanding, and it's culturally it's a very different approach to the geothermal energy. So it's something I think we in Europe we just don't consider at all the cultural heritage that geothermal energy has. Which brings me to sort of personal question. So in your Waku Waku camp, were there any concerns about the risks, the technical risks? So here in Europe, there's a lot of worries and a lot of research is done how we control, mitigate, assess the risks of geothermal operations, be it induced seismicity or subsidence, or people are concerned about some radioactivity if you have hot fluids coming from the subsurface. Is that something that you experienced in your Waku Waku camp that was a matter of concern, how geothermal operations could not just change the cultural importance of the onsen tradition, but also possibly create some seismic events or create some trigger some natural hazards, some geological risks? Is that of importance in Japan, or are people less concerned?
Yeah, thank you. Yeah, I think about the seismicity, I think around the geothermal power plant, they need to be careful about the seismicity, so for the citizen near the power plant. But currently, that is not big issue compared to the other issue, because Japan has a lot of the earthquake, and so people, I think people worry about, but not so much. But I think most of the people worry about if we use the hot water from the geothermal reservoir, then we cannot the hot spring water is dried out due to the geothermal development. Then, like, many people really like the onsen, like bathing. So we want to keep this culture. So I think this is the science people and engineering people try to explain the geothermal power plant doesn't affect on so much problem for like drying out of the hot spring, but it's quite difficult to explain because we cannot say it's 100% sure we can keep the hot spring water in the underground. So I think that is more important for the Japanese people.
Completely different perspective, Sebastian, than in Europe.
I remember so when we were in Japan, we had we experienced a 5.5 and 5.8 earthquake, and the landlady we stayed with, so that's nothing. And again, so for us in Europe, you think this is quite a jolt here. That's sort of quite interesting.
Normal, yeah.
No one, it's not even.
May I jump in, Sebastian, and just follow up on what you just said about, so now you see that now you try to engage, Anna, with the society. Is there, the attitude is not about us to educate, for example, it's more about to engage and also learn from the society. That what are the perceived risks of the geoscientific projects that we would like to plan? What was the main take-home message that you also experienced all these interactions, that we should also take it into account for other settings, like in Europe, as Sebastian was mentioning, or in US or other places?
Through this activity, what is the message for the what is the output or like message of the
what did you learn from this process of engaging with society, that you would say, well, of course the technicalities are different in different cultures and in different countries, like in Europe or US or Middle East or other places, but still you would see that when you are dealing as a researcher or scientist with society, you should keep in mind to do these aspects always. These are the principle behind connecting science, as Larry says, with the society. So do you have advice for us in different cultures and different settings to take account from your experience?
Yeah, I see. Thank you. So it's a bit difficult, but I think if we have a different culture, like a different country or different job or different generation, then like our consciousness is different. First, we need to think about it. Then even we try to like explain that is true. I think that is true. But if the other people think about it, they don't think that is true. So this mismatch is occur always. So first we need to think about the important thing is I think most of the scientists or engineering or like previous myself is only focusing on the like logical phase, like how to solve the problem. Like always think about how to solve the problem. So, but I think everyone need to consider what is problem. It's first. So it's then it's better to talk with the other people, like discuss with other people about what is the problem for each other. So that is important to make society smooth, I think. Sorry, my answer is not great.
But that's good still to listen and don't presume that would be what they would perceive. So just be open and listen first and see if the risks for them is keeping the hot tubs running or subsidence, for example, be mitigated. And as you said, generations also have different perspectives of the system as well. Could you also impact the society now by these camps? Would they now go and say, we want geothermal tomorrow? Was that a significant change in the locals that you observed after the camps?
I think our camp is not big impact on like spontaneously, but yeah, I think the important is there are people who didn't know anything about the geothermal energy before, but they noticed, oh, geothermal, there is a geothermal energy. That like notice is important for us. So I think this camp is this first step. So but anything more, we didn't do anymore. So we just this camp. The purpose of this camp is to the purpose of this camp is for the people who didn't know or didn't consider anything about the nature or energy. Then just the idea of the energy come to their mind.
Which is quite a smart, I would say. I mean, it's more science camp without any biases. It's more about just to learn about the process and you take your decision. I see. Very smart. Thanks a lot, Sebastian. Thanks.
Thank you.
Thank you very much. And I think there are no further questions from the audience. And we have asked also our questions, Hadi and I. So thank you very much, Anna, for a great talk, especially on the Waku Waku side. It's really inspiring.
Yeah.
Thank you to our audience for excellent questions. And again, to you, Anna, for answering them so diligently. And Hadi, over to you for some final comments.
Thanks. Yes, I'd like to take the chance and announce our next week's speaker will be Professor Tony Kovsek from Stanford University. Tony will give a lecture about multimodal imaging and machine learning to enhance microscope images of porous materials. So until next week, the same time, 4 p.m. Central European, 3 p.m. British time, 7 a.m. California, 11 midnight Japan. I'm going to say that also. Stay happy, healthy, and tuned, and enjoy your week ahead. All the very best, and see you next week. Bye-bye.
Thank you much. Thank you, Anna. Bye-bye, everyone.
Bye-bye.
Bye.